Okay, the very last thing we want to look at is the idea of changing the subject of a formula. You recall that earlier I spoke about formulas such as v equals u plus at, which is a formula that tells you your speed if you know your initial speed and your acceleration. But I mentioned the fact that this first variable on this side of the equation was called the subject. So changing the subject would be rearranging this equation to make something else a subject. So for example, make t the subject. So if we're making t the subject, I need to make t equal. So it's like solving an equation, just no numbers involved, just letters only. To do that, I'm still going to do exactly the same as I would have done if there were numbers here. I'm going to treat v, u, and a as a number. So I'm going to get rid of u by subtracting u from both sides. So v minus u is equal to at. Finally, I need to get t on its own, so I'm going to divide everything, because it's a times t, using the inverse operation, divide by a. That leaves me just t is equal to, and I have v minus u over a. Interesting to note at this point, when you have a division, what you're dividing by can't be 0. So I could make a little note over here that a is not equal to 0, division by 0 being undefined. Alright, here's a second example, making r the subject of s equals a over 1 minus r. This one's a little bit trickier. I've got this s equals a over 1 minus r. My r's on the denominator. First thing I want to do is I want to get this to the numerator. So I want to multiply both sides by what's on the denominator. I'm going to put grouping symbols around them to remind me that I have to multiply by that. Times both sides by that. So here we go. This and this I can cancel because they're connected by this multiplication. And so I get s lots of 1 minus r is equal to a. Now I want to make r the subject. So I need to get rid of this s. So I'm going to divide both sides by s. 1 minus r is equal to a over s. I now need to get rid of this 1, so I'll subtract the 1 because the 1 itself is positive. Subtract 1. Negative r, keeping that in mind, is equal to a over s minus 1. And then to get rid of this negative r equals a over s minus 1, I want to get rid of the negative 1. Times everything by negative 1. So times by negative 1 times negative 1 times negative 1. Everything gets multiplied. This becomes positive r. This is a positive times a negative. Negative a over s. Negative times negative makes a plus 1. And now my r is the subject of a formula. Over here I chose to divide by s. If I had have expanded by s, I would have again got r as the subject of the formula. And it just would have come as a slightly different looking answer. Why don't you have a go at doing the expansion and rearranging it and see if you can see the differences. One more example. This one has got a little bit of a twist in it. I want to make h the subject of this. Notice there's two h's. So my goal here will be to get both h's to the same side. So firstly, like in the last example, I'll multiply both sides by h minus 3. Oops. This side, they cancel. This side, I'm left with y, h minus 3 is equal to h. Now, unlike last time, I'm not going to divide by y because I want to collect my h's to the same side. So I'll expand this out. I'll get yh minus 3y, is equal to h. Now I'll collect my pronumeral, h to the same side. You notice I'm ignoring the y. I'm treating it like a number. I'll subtract yh from both sides. Negative 3y is equal to h minus yh. Now some of you may be thinking this is not much clearer at this stage. I need to make h the subject. What I need to do here is I need to factorise. So I'm going to factorise it now, and I'm going to have negative 3y is equal to h outside of 1 minus y. Common factor of h. Now I've got h times something, so to get rid of that multiplication I know I can divide by 1 minus y. I'll do it on both sides. This side will cancel, leaving me just h is equal to, and this side, negative 3y over 1 minus y.